Welcome to AC Machines class. Today topic is circle diagram. So how to draw the circle diagram? First we need some data before drawing the circle diagram. We need no load test data and blocked rotor test data. From the no load test data we need no load current and no load power factor. From that the angle of lag, which is phi naught, no load power factor angle, and also from block rotor test we need short circuit voltage and short circuit current and short circuit power factor. From that power factor angle phi SC. So from this data we have to find out short circuit current under normal condition, that is ISN. ISN is the short circuit current for normal voltage, that is ISN equal to ISC into V1 by VSC. So from this data we have to follow these steps to draw the circle diagram. Okay, so I will draw a circle diagram, model circuit diagram. Actually this circle diagram need to be drawn in a graph sheet. Okay, you have to draw the circle diagram in a graph sheet, but I am explaining the same thing here in the white paper, but you have to draw the circle diagram in a graph sheet. Okay, so first step is to draw a vertical line representing the rated voltage V1. Okay, so first we have to draw a vertical line representing V1. Okay, this is V1. Okay, same as the vector diagram. We have to, let us consider this as y-axis. Okay, now what is the second step? Select a suitable scale for current. Draw line OA lagging V1 by an angle phi naught equal to no load current I naught. Okay, that means we have to draw the current, no load current I naught, which is lagging V1 by an angle phi naught. But here we have to take some scale because the graph sheet length is limited around 30 centimeters diagonally and I think 20 centimeters horizontally. So we have to take some scale. For example, that scale is dependent on this value, short circuit current under normal condition. So if this one is around 30 amperes, then we can take 1 centimeter equal to 1 ampere. If it is 40, 50 or 60, then we have to take 1 centimeter equal to 2 amperes. Okay, so you have to take that suitable scale. If suppose 1 centimeter equal to 1 ampere, then if no load current is 2 amperes, then length OA is 2 centimeters. So OA is 2 centimeters, and the angle you have to measure the first we have to take an angle phi naught. Suppose the phi naught is 80 degrees or 85 degrees. No load, actually generally no load power factor is very low. It is ranges from 60 to 80. So we have to, it is lagging V1. This is I naught. OA represents no load current. Okay, so we have to draw also one horizontal line, x-axis. Okay, draw a horizontal line. Now after drawing OA, draw line OB. Okay, this is OA and OB is ISN. OB represents ISN. See, draw a line OB lagging V1 by an angle phi SC equal to short circuit current for normal voltage. Okay, vector OB represents the rotor current I2 dash as referred to stator. Okay, that is ISN. So how to draw ISN by an angle phi SC? So draw this one by dotted line. Okay, because this line is not much important, so we have to draw this by dotted line. This is OB and the angle V1 OB is phi SC. Okay, so now join AB. Okay, join AB. Generally the difference between OB and AB is very less. Okay, so join OB which represents output line. OB is the output line. Okay, now we have to draw a line horizontal from A. We have to draw a horizontal line from A and draw one perpendicular bisector to AB. AB, you have to draw a perpendicular bisector. You know how to draw a perpendicular bisector like this. Okay, so perpendicular bisector, let this be C. So from with C as center and CA as radius, draw a semicircle. Draw a semicircle ABD. Okay, draw a semicircle ABD and next draw a vertical line from B. It will cut this is no load line. It will cut the no load line in F and base line at G, and we have to divide this line BF into two parts such that BE is equal to rotor copper loss and EF equal to stator copper loss. This is rotor copper loss at and this is stator copper loss. Okay, this rotor copper loss and stator copper loss, these are at blocked rotor test under normal voltage condition, and if you join AE with a straight line, this is torque line. This torque line, this is output line, and this is no load line. Okay, and this portion FG represents no load losses and FE represents stator copper losses and BE represents rotor copper losses. Okay, so now if you want to find out this is about this is the circle diagram, but how to compute the performance? So how to compute the computation of performance? So you have to draw as the applied voltage V1 is, and as the applied voltage is drawn vertically, all the vertical components are represents energy components, that is power components. The vertical line AQ represents here AQ. This is AQ represents no load losses. Okay, and torque line under block rotor condition. Okay, all this. Okay. So how this is relevant? Okay, how to find P? This is important. This one, operating point or full load point P. So how to find P? Let me suppose the full load output is suppose some 3 kilowatts or 4 kilowatts. So we have to find the power scale. We have to determine the power scale. That is, for 1 centimeter, how much power is represented on the graph. That means here total BG is the total loss under block rotor condition under normal power. That means WSN is equal to BG. WSN equal to BG. How to find WSN? WSN is equal to WSC into V1 by VSC whole square. So from this data we can find WSN, and you will equal to BG. Suppose BG is 10 centimeters and WSN is 10 kilowatts or 10,000 watts. Then 1 centimeter equal to 1 kilowatt. That is the power scale. 1 centimeter equal to 1 kilowatt. This is just example. Okay. So now if the full load is 3 kilowatts, then the full load scale, from the full load scale, the vertical line representing BL, which is equal to output, full load output is 3 centimeters. Okay, so we have to draw vertical line BL, which is equal to full load output. This is full load output. So from this we will find the point P, operating point P. How? We have to draw a line, parallel line to the output line from L. So like this, you have to draw a parallel. This line and this line are parallel to each other. Okay, and this line will cut the semicircular 2 points. We have to consider first point, name it as P. Okay, this is the operating point P at full load point P. Now you have to join OP. Join OP. Okay, now this OP represents full load current. Okay, OP represents full load current, and this angle between V1 and OP is full load power factor angle. Okay, and cos phi FL is a full load power factor. Okay, full load power factor. Okay, so and now draw a line vertically from P. So it will cut this output line. It will cut the output line at M and torque line at N and no load line at J and baseline at K. So all these points, that means here MP is the actual output. MP is the actual output. MN is the rotor copper loss. NJ is the stator copper loss. And JK is the no load loss. That means this MK is the total loss at full load, and MP is the output. So we know the output, we know the losses, we can find the efficiency. Okay, so how to find, see here, how to find out different factors. Here see full load current is OP. Okay, full load current, OP is the full load current. Next, full load power factor angle phi naught, that means angle V1 OP. So already discussed. Or see angle V1 OP, or cos phi 1 is equal to PK by OP. So cos phi 1 is phi FL or phi 1. Okay, phi 1 or phi FL, both are same. So cos phi 1 is the PK opposite side by hypotenuse OP. Okay. Now full load slip S equal to rotor copper loss by rotor input. Rotor copper loss is Mn by Pn. See, Mn is the rotor copper loss and Pn is the rotor input. Okay, Pn is the rotor input and Mn is the rotor copper loss. Therefore slip equal to Mn by Pn, and speed N equal to Ns into 1 minus S. So if you know the slip, you can find the speed. And efficiency, output by input. Output is PM. PM is the output and PK is the input. Therefore efficiency is PM by PK. Next, maximum output, HI. So how to determine maximum output, HI? So we have to output line, we have to draw a tangential line parallel to the here this point is H, this point is H. So and if you draw a perpendicular line here, this one is I. So HI is the maximum output. And also if you draw a tangent line to the torque line here, then it is R, and yes, this RS line is the maximum torque. Okay, and full load torque is PN. PN is the full load torque. Okay, and starting torque is BE. Okay, BE is the starting torque, and slip at maximum torque. Slip at maximum torque is TS by RS. Slip at maximum torque is, where is T? Oh, okay. This is T. So this is T. TS by RS. This is the slip at maximum torque. Okay. So this is just a sample diagram. If you solve one problem, then you will find the actual values. But here, if you want to solve a problem, actual problem, we need a graph. Okay. So I will show this one. For example, here, see in this example, no load test data is given and block rotor test data is given. and they ask to find the load current, power factor and efficiency at full load and full load slip and maximum horsepower output. The stator and rotor copper losses divided equal in the block rotor. So the E point, this line is given for to find the point E. So first no load data is noted down. No load data V1 400 volts, I0 to cos phi 0 0.2, phi 0 is 78.5 degrees. Then block rotor test. From the block rotor test they find the VSC, ISC and phi SC. From cos phi SC, phi SC is 66 degrees. So short circuit current for normal voltage. Here ISN is equal to ISC to V1 by VSC, that is 50 into 400 by 200, 100 amperes. So if the it is 100 amperes, you cannot, so you have to select the suitable scale. If 1 centimeter equal to 5 amperes, then ISN will be 20 centimeters, which can be fitted into the graph easily. So that's why they taken 1 centimeter equal to 5 amperes, and no load current 9 amperes will become 1.8 centimeters, approximately 2 centimeters. Okay, after selecting the current scale, we have to select the power scale also. To select the power scale, we have to find WSN. How to find WSN? First we have to find WSC. WS equal to root 3 VSC IC cos phi SC, which is equal to 6928 watts. So from this, WSN equal to WSC to V1 by VSC whole square. So you will get 27,713 watts. So this power is equal to BG length in the circle diagram. This BG length, you have to, before finding the power scale, before finding up to this point, after selecting the current scale, we have to draw the circle diagram, draw the whole of the circle diagram except BL portion. Before starting to proceed further up to this point, up to point B and G, we have to draw the circle diagram before finding the power scale. After finding the power scale, which is 3421 watts per centimeter, then we have to find out the full load output in watts to the centimeters. So dividing the full load output with respect to power scale, we will get 4.3 centimeters. Okay, so from this we have to draw BL, full load output, which is equal to 4.3 centimeters. From that, again this line PL line is parallel to output line. Okay, and also this line is parallel to AB to find the maximum output. HI is the maximum output. This line is parallel to AB. Okay, so from that this point, see it cut the circle diagram at 2 points, but we consider this point as P. So and by joining OP and by drawing vertical line PK, we will find, and also finding the points M, N and J, we will find the different values. That is full load line current equal to OP, which is equal to 6.2 centimeters, that is 31 amperes. So from this O to P, it is 6.2 centimeters. We have to find this in graph, and also angle has to be measured, VOP angle, that is 31 degrees. So therefore cos phi 1 equal to 0.85 lagging. Or you can find another way, PK by OP similar to 0.85 lagging. Next, full load slip Mn by Pn, same formula, efficiency PM by Pk 81%, and also maximum output HI 6.4 centimeters, so 21,897 watts, and maximum HP is 29.77, is British horsepower 735.5. If you divide watts divided by 735, we will get HP. Okay, that is the one example. Okay, you have to draw it in graph and submit. Thank you.